3 consecutive positive odd integers a, b, c satisfies b squared minus a squared equals 344. And c squared minus b squared is positive. Therefore, a is less than b less than c. A is b minus 2, c is b plus 2. What is the value of c squared minus b squared? B squared minus a squared equals 344. So b minus a times b plus a equals 344. B minus a equals 2. So b plus a equals 172. And a equals b minus 2. So 2b equals 174. B equals 87. C equals 89. So c squared minus b squared equals c minus b times c plus b, which is 2 times 176, 352. Evaluate 29 squared. This is 30 minus 1 squared. 30 squared minus 60 plus 1, 841. 299 squared. 300 minus 1 squared. 940 minus 600 plus 1, 89401. 2,999 squared. 3,000 minus 1 squared. This is 9 million minus 6,000 plus 1, which is 8994001. How about the sum of the digits of 2 followed by 7 9? This is 3 times 10 to 7 minus 1 squared. 9 times 10 to 14 minus 6 times 10 to 7 plus 1. So we will have 8, 7 digits, another 7 digits. This will be 1. This will be 60. Then we have 4 and 6, 9. Over here. The sum of digits is going to be 8 plus 1 is 9. So 9 times 7 plus 4, 67. Compute this complicated product or rational number. Let's see the numerator. There are many terms. The first term is 1998 squared minus 1996 squared. So it is 2 times 1998 plus 1996, which is 3994. Then look at the second factor. 1998 squared minus 1995 squared, which is 3 times 3993. Then this pattern is going to continue. The last one, we have 1998 times 1998. Now let's look at the denominator. The first term is 1 times 3993. The second factor gives us 2 times 3992. The last term gave us 1997 times 1997. So many terms will be cancelled. For example, so this is 2, 3, and then we'll have 4, 5 until 1998. And here we have 1, 2, 3, 4 until 1997. So these will be cancelled. So 1998 will stay, and 1 will stay. Then let's look at the second factor inside each parenthesis. 3994, 3993, and decrease by 1 each step. In the end, 1998. And the denominator, 3993, 3992, and then 1997. So these will be cancelled. And this term will stay. This term will stay. So in the end, we have 3994 times 1998 divided by 1 times 1997. And this is 2. So we have 3996. Rationalize the denominator of 2 over 2 minus 4th root of 2. We know x to the power 4 minus y to the power 4 is x squared minus y squared, x squared plus y squared, which is x minus y, x plus y times x squared plus y squared, which is x minus y times x cubed plus x squared y plus xy squared plus y cubed. Okay, now we make x equals 2, y equals 4th root of 2. And we are going to multiply both numerator and denominator by this thing. This basically is 2 over x minus y. If we multiply this factor, we are going to have x to the power 4 minus y to the power 4. Numerator is 2 times this polynomial. And the denominator will be 2 to the power 4 minus 4th root of 2 to the power 4, which is 16 minus 2, which is 14, which is an integer, a rational number. Okay, so this 2 cancels with the factor 2 in 14, so get 7. Therefore, we have this equals 1 over 7 times x cubed, 8, plus x squared y, 4 times 4th root of 2, xy squared plus 2 times square root of 2, plus y cubed, 4th root of 8. Without using a calculator, find the largest prime divisor of 5 to the power 12 minus 2 times 10 to the power 6 plus 2 to the power 12. So this is 5 to the power 6 squared minus 2 times 5 to the power 6 times 2 to the power 6 plus 2 to the power 6 squared, which is 5 to 6 minus 2 to 6 squared. The 5 to 6 minus 2 to 6 is 5 cubed squared minus 2 cubed squared, which is 5 cubed minus 2 cubed times 5 cubed plus 2 cubed, which is 5 minus 2 times 25 plus 10 plus 4 times 5 plus 2 times 25 minus 10 plus 4. So this is 3 times 39, 3 times 13 times 7, and this is 19. So 3 squared times 7 times 13 times 19. So 5 to the power 6 minus 2 to the power 6 squared would be 3 to the power 4, 7 squared, 13 squared, then 19 squared. The largest prime factor is 19. Two non-zero real numbers, a and b, satisfy ab equals a minus b. Find all possible values of a over b plus b over a minus ab. Let's see, this is a squared plus b squared minus a squared b squared divided by ab. Now, ab is a minus b, so a squared b squared is a minus b squared. So this thing is a squared plus b squared minus a squared plus 2ab minus b squared, then divided by ab. So a squared cancel, b squared cancel. We get 2. The expression x to the power 5 plus y to the power 5 can be written as a product of x plus y and another factor. Find that factor. So we are told that this can be written as x plus y times something. We need to find that term. What we can do is we try to make x plus y factor. So we can do x to the power 5 add x to the power 4 times y. This will give us x to the power 4 times x plus y. But then we need to subtract x to the power 4 y. In order to get x plus y term using this term, then we need to subtract x cubed y squared. So we get negative x cubed y, x plus y. Then we need to add back x cubed y squared. And then we add x squared y cubed. So this will give us x squared y squared, x plus y. But we don't need x squared y cubed, so we need to subtract it. Okay, then we subtract x y to the power 4 in order to have the factor x plus y, which is negative x times y cubed. Then we need to add back x times y to the power 4. Finally, we add the term y to the power 5. This gives us y to the power 4 times x plus y. Altogether, we have x plus y times x to 4 minus x cubed y plus x squared y squared minus xy cubed plus y to the power 4. And you see there are 1, 2, 3, 4, 5 terms in this factor. Now we can do the same thing for x to the power 7 plus y to the power 7. Write it as a product of x plus y times something. Then this is what we do. X to the power 7 plus x to the power 6 times y. Then minus x to the power 6 y minus x to the power 5 y squared plus x to 5 y squared plus x to the power 4 y cubed. Then minus x to the power 4 y cubed minus x cubed y to the power 4. Add back x cubed y to the power 4. Then add x squared y to the power 5. Subtract x squared y to the power 5. Subtract x y to the power 6. Add back x y to the power 6. Finally, add y to the power 7. Okay, then this line is x to 6 times x plus y. This is x to 5 times y, x plus y, negative. This one is x to 4 y squared, x plus y. This one is negative x cubed, y cubed, x plus y. This one is x squared, y to the power 4, x plus y. And this one is negative x y to the power 5, x plus y. This one is y to the power 6, x plus y. Okay, putting everything together, we have the factor x plus y. Then we have the factor x to 6 minus x to 5y plus x to 4y squared minus x cubed y cubed plus x squared y to the power 4 minus x y to the power 5 plus y to the power 6. X to the power 2n plus 1 plus y to the power 2n plus 1. We can just do the same thing. We'll get x plus y times x to 2n minus x to 2n minus 1y plus x to 2n minus 2y squared minus and so on. And in the end, we are going to have plus x squared y to the power 2n minus 2 minus x y to the power 2n minus 1 plus y to the power 2n. Note that all three examples, all exponents are odd. And this will not work if the exponent is even. Well, some situations we may have other techniques to factor it, but in general, this will not work. Let's think about it. Now, if we have an odd power x to the power 2n plus 1 plus y to the power 2n plus 1, if I make x equals negative y, then I will have negative 1 to the power 2n plus 1 times y to the power 2n plus 1 plus y to the power 2n plus 1. This is negative 1. So this whole thing will be 0. What does it mean? It means x plus y should be a factor of the polynomial. That's why we can write it as x plus y times something. Then in the factor form, if we make x equals negative y, for sure this will be 0. This is the deep reason why this works. Use the figure at right to prove that a plus b plus c squared equals a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. Let's see. This is a squared, b squared, c squared, ab, ac, AC, BC, BC. Obvious, right? How many different triples of numbers ABC satisfy the equation a squared plus BC equals b squared plus AC? ABC are integers from 1 to 5 inclusive. Let's rewrite this equation as a squared minus b squared equals AC minus BC. Then we have a minus b times a plus b equals a minus b times c, which is a minus b times a plus b minus c equals 0. We either have a equals b or a plus b equals c. Now consider the first case. A equals b, and this number can be 1, can be 2, can be 5, and c can be anything, 1, 2 to 5. So 25 combinations. Now consider case 2. We do not want to overcount, so we assume a, b are not the same. Then if a, b are not the same, a plus b equals c. What are the possibilities? It could be 1 plus 2 equals 3, 1 plus 3 equals 4, 1 plus 4 equals 5, or 2 plus 3 equals 5. Then we can assign a, b in 2 different ways for each situation. There are 8 ways. 25 plus 8 equals 33. Final answer, 33. A triangle is a right triangle if the sum of the squares of the 2 smallest sides equals the square of its largest side. If n is a positive integer here, must the triangle with sides this be a right triangle? Let's see. 6 times 10 to the power n plus 2. 1125 times 10 to the power 2n plus 1 minus 8. And 1125 times 10 to the power 2n plus 1 plus 8. This is the largest number. Now let's call this x, y, and this one z. Then z squared minus y squared is what? Z minus y times z plus y. Z minus y, simple, 16. Z plus y is 2250 times 10 to the power 2n plus 1, which is 4 times 15 squared times 10 to the power 2n plus 2, which is 60 times 10 to the power n plus 1 squared, which is 6 times 10 to the power n plus 2 squared, which is x squared. So x squared plus y squared equals z squared. This is Pythagorean theorem for right triangle. So the answer is yes. Determine square root of 1 plus 50 times 51 times 52 times 53. Let's assume x equals 51.5. Then this quantity is square root of 1 plus x minus 1.5, x minus 0.5, x plus 0.5, x plus 1.5. X minus 0.5 times x plus 0.5 equals x squared minus 0.25. X minus 1.5 times x plus 1.5 equals x squared minus 2.25. Multiply them together. We get x to the power 4 minus 2.5 x squared plus 0.25 times 2.25. This number is 1 over 4 times 9 over 4, which is 9 over 16. So 1 plus this thing is square root of x to the power 4 minus 2.5 x squared plus 9 over 16 plus 1, which is 25 over 16, which is 5 over 4 squared. And 2.5 is 5 over 4 times 2. So this thing is x squared minus 5 over 4. X is large, so we know x squared minus 5 over 4 is a large number. It's positive. Then we need to calculate x squared. X squared equals 50 plus 1.5 squared, which is 2500 plus 50 times 3, 150 plus 1.5 squared, 2.25. So 2,652.25. Okay, therefore x squared minus 1.25 is going to be 2,651. Factor x to the power 4 plus 4 times y to the power 4. We add 4 times x squared y squared, subtract 4 times x squared y squared. Then we get x squared plus 2y squared squared minus 2xy squared. Use difference of squares. X squared minus 2xy plus 2y squared times x squared plus 2xy plus 2y squared. Express 2 to the power 22 plus 1 as the product of two 4-digit numbers. This is 2 to the power 22 plus 1. Let's add 2 times 2 to the power 11, subtract 2 times 2 to the power 11. Then we get 2 to the power 11 plus 1 squared minus 2 to the power 12, which is 2 to the power 6 squared. So 2 to the power 11 minus 2 to the power 6 plus 1 times 2 to the power 11 plus 2 to the power 6 plus 1. This is 2048 minus 64 plus 1, and 2048 plus 64 plus 1. 1985 times 2, 1, 1, 3. Simplify the expression square root of 2 minus 1 to a power 1 minus square root of 3 divided by square root of 2 plus 1 to a power 1 plus square root of 3. We need to rationalize the denominator. We multiply the denominator by square root of 2 minus 1 to a power 1 plus square root of 3. And the same thing for the numerator. Then the numerator is square root of 2 minus 1 squared. Denominator is 2 minus 1 to a power 1 plus square root of 3. So this is just 1. 3 minus 2 times square root of 2. Without a calculator, find the sum of the digits of the number 2003 to a power 4 minus 1997 to a power 4. Let's say x equals 2000. Then this is x plus 3 to a power 4 minus x minus 3 to a power 4, which is x plus 3 squared minus x minus 3 squared times x plus 3 squared plus x minus 3 squared. Using difference of squares again, we get 6 times 2x times 2 times x squared plus 9. So 24x x squared plus 9. X is 2000. 48000 times 4000009. What is this big number? 48 times 4. That is 192. Then we have this number plus 9 times 48000. 432000. So in total it's 192,000,432,000. We need to find the sum of the digits. That's going to be 12 plus 9, which is 21. This is the end of the video.